All right, continuing on with rational expressions. So we're going to go back to not equations, just expressions. What we want to do is work on multiplying and dividing at this point and then simplifying, of course. So we have our directions up here at the top. We want to factor each denominator. We're going to follow along the exact same thing that we did previously. And then I'm going to factor everything that I possibly can, so even the numerators. And then remember, when you multiply fractions, you multiply straight across, so top times top, bottom times bottom. But if you can simplify as you're going before you multiply, that's ideal. Less work at the end. Then if you're doing division, you want to make sure you're still going to go through and do all the factoring process. You want to take the second fraction, flip it over, so get its reciprocal, and then you're going to times by that. So division turns into multiplication. Okay, so more factoring, of course. So before I continue, I highly recommend that you pause, see if you can factor these, and then come back and check your answer with mine. Okay, so I have everything factored now. Quick check, make sure that we match. And then from here, I want to simplify before I actually multiply. So if there's anything that is on the top of the fraction that matches exactly with something on the bottom of the fraction, doesn't matter if it's like diagonals, so maybe anything down here that matches with anything up there, you can simplify those. Or if you have anything here and here, you can simplify those as well, as long as they match. So I see that I have a 2x plus 1 in the denominator, and all I'm going to do is find the 2x plus 1 that's also in the numerator. Those are going to simplify, so let's go ahead and cancel those out. Then I have, let's see, it looks like I have an x minus 4 and an x minus 4. One on the top, one on the bottom. Those can cancel out as well. So do I have anything else? Yes, I do. I've got an x plus 3 that I could get rid of. So x plus 3, x plus 3. As long as it's one on the top, one on the bottom, one on the top, one on the bottom. Then you could simplify those because x plus 3 over x plus 3 is just 1. So that can simplify out. If I take a look at what I have, it looks like all I have left is 2x minus 1 all over 5. So I'm going to take my 2x minus 1 all over 5, and then I really do want you to follow through with the whole idea of excluded values. Anytime we started with an x in the denominator of a fraction, y'all know that we cannot divide by 0. So if I look back at my original question, I have this 2x plus 1 here. Well, I'm going to do a little bit of zero product property. 2x plus 1 equals 0, so the thing it's not allowed to be. Then if I solve that, I know that x cannot equal a half. Then I'm going to take a look at the x plus 3, so x cannot equal negative 3. And then I'm going to keep going. Then 5 will never be equal to 0, so you don't have to worry about that. But then the x minus 4, of course. So let's go ahead and tag that into the list. So if we take a look at this, I think we have our entire answer here. It's going to be our fraction, and then the things that x is not allowed to be. Moving on to the next problem, we're looking at the exact same situation. It's still multiplication, so we want to factor completely as much as possible, top, bottom, cancel anything out that you can match top and bottom. Remember, it's one top, one bottom. Can't cancel extras. And then from there, write down the simplified fraction and then identify your excluded values. So take a minute, pause the video, and then see if you can see if our factors match. Okay, so here's my factorization. It's still multiplication, so I don't have to do any flipping business with the second one. So let's go through and see if I can find things that match top and bottom. So it looks like I have an x minus 2 and an x minus 2, so I can go ahead and simplify those out. And then I think I've got more here. Let's take a look. We've got a 3x minus 2 and a 3x minus 2, so those are going to simplify. Do I have anything else? Yeah, I've got an x plus 1 and an x plus 1. So let's go ahead and simplify that as well. So I've got my x plus 1 and my x plus 1. So those are going to go away. And then it looks like the only thing I have left is an x minus 1 and a 2x minus 3. So I'm going to have an x minus 1 all over a 2x minus 3. And then because x is in this expression and it's in the denominator of the fraction, I'm going to go back and see all of the things that would have made the denominator 0. Remember, at no point in time is the fraction allowed to have a 0 in the bottom. It doesn't matter if it's the beginning stage, middle stage, end stage, you can never have 0 in the bottom of a fraction. So I'm going to go back up to my factored form, so I think it's a little bit easier. And if I take a look at this first one here, that's going to give me 2/3. So it cannot equal 2/3. If I take a look at the second one, that one's going to give me 3/2. So I know I cannot have 3/2 in the denominator. Okay, let's keep going, see what else we can find. So then if I look at this next one, an x minus 2, okay, so you can't have 2 then. And then this very last one here, it looks like we cannot have -1. So we're just going to list off all the things we can't have. So ultimately, when we're doing this, we are going to factor everything that we possibly can. If it's multiplication, just leave it as it is in 1 for 1, top and bottom, see if you can cancel things out. And then if it's division, you're going to still factor everything, and then you're going to flip the second guy and turn it into multiplication. Let's take a look at the next one. All right, okay, so here we have a division. All right, so go ahead and pause the video, see if you can get the factorization correctly, and then remember you're going to take this entire second fraction in its factored form and completely flip it over. We're going to turn that guy into multiplication. Okay, so I did a couple of things at once. I went through and factored everything, but then I changed this division sign to a multiplication symbol, but then when I did it, I wanted to swap those two things. So let's see if we can simplify some stuff out and then take a look and see if we can figure out what the answer is supposed to be here. All right, I see an x plus 1 and an x plus 1, so let's get those out of there. I see an x plus 2 and an x plus 2, so let's get those out of there. Do I have anything else? I don't think so. So let's go ahead and write out what we have left over. So what we're going to have on the top is an x minus 1 times an x minus 2 all over, and then we have a 4 times x squared minus x plus 1. Okay, so we still need to do our excluded values. When you started with a division problem, so I'm going to go back and said what I said on the previous slide. At no point in time is the bottom of the fraction allowed to be 0, even in the original question. So if I go all the way back up to the original question and I take a look, I need to make sure that I pay attention to all of the denominators there. None of that could be equivalent to 0. So I need to make sure that I list off all of the things, even at the final answer, even at all the stages in between. So if I take a look at the 4x plus 8, so I'm looking at this first guy here, 4x plus 8. Well, I turned it into factored form down here. It was 4 times x plus 2. So I know, well, the 4 can't be 0 anyway, so I know I cannot have -2 from the x plus 2. Okay, now I'm going to take a look at the x squared minus 4. Well, the x squared minus 4 turned into a factored form. However, it is not on the bottom of the fraction anymore. I put it right there. So inside the green box there, I have this factorization. So I can't have 2 or -2. So -2 is already in my list. I don't have to duplicate that, but I do need to put the 2 in the list. But then as we proceed, because I flipped things over, I now have to pay attention to the brand new denominator that I created there. Again, can't divide by 0 at any point in time. Well, the very first parenthesis is going to give me -1. The second one I want to stop and think about for a second. So I have this x squared, I'm going to do a little bit of side work here. I have this x squared minus x plus 1, and I'm doing zero product property. I'm trying to figure out what this can't be. If I go through and I try to solve this thing using quadratic spectrum integrated 2, this isn't factorable. So all I care about really is if I'm going to get a real answer out of this. So for me, all I'm doing is a quick check on the radical part or the root part from the quadratic formula. So I'm just going to look at b squared minus 4ac to see if I need to continue seeing if this is a real answer or not. Okay, so that's going to give me -1 squared minus 4 times 1 times 1. So that's going to give me 1 minus 4, that's -3, which means from the quadratic formula, this is going to be imaginary. We're only dealing with real numbers right now, so I'm not going to get excluded values from here. So there are no excluded values from this guy. That's because I'm only looking for real, and the only type of answers I'm going to get from that are going to be imaginary. Okay, so I think we have our final answer here now. So I don't have any excluded values from that guy, which means I have this fraction and my excluded values. So let's take a look at the next one. Okay, let's see if you can do this all the way through. So we're going to factor everything, top and bottom. Since this is a division problem, let's turn it into multiply. And then you're going to flip those guys around. Don't forget that when you're doing excluded values, you want to make sure that you take that denominator into consideration. So every single denominator throughout the problem needs to be taken into consideration. So pause the video, see if you can find the final answer. Okay, here's a pit stop check if you want to look and see if we have the exact same factors or not. So check your factors against mine and then pause it again, see if you're canceling out the correct things, see if we can get the correct answer, and don't forget all of the excluded values. Okay, so here's my fraction, x minus 4 over x minus 2. All of my excluded values. Okay, my excluded values are going to have to come from all of the denominators that started. And since we're going to be flipping over this whole second fraction, you see my orange arrows, we're also going to pay attention to that. Really, the only place I'm not looking for excluded values is right at the top of the very first fraction. Like I kind of ignore that guy because at no point in time does it ever become a denominator. So let's get rid of that. We're only looking at the blue. So knowing that, all you're going to be looking at is everything down there and everything there. So all of those things could have been 0 at some point in time. Those become excluded values. Okay, see if you can list them all out. Hopefully we match at this point. So go ahead and take a look at your excluded values. We should have the entire fraction, x minus 4 over x minus 2, and then x cannot equal, apparently 4 things for this one. So let's go ahead and take a look at the next question. Okay, so now we're talking about being able to simplify these things. This whole idea of fractions in fractions, so like a division inside a division. This is unpleasant to look at. We want to make sure that we clean this up. So we're going to factor each denominator if possible. So if we can clean things up, we're going to clean things up as we go. Then we're going to multiply each term in the complex fraction by the greatest common factor. I'll show you what that means. Combine like terms in the numerator and the denominator, factor out the new numerator and denominator if able. Okay, so my one huge recommendation here is this whole idea of multiplying by 1. So we've done this a couple of times in the past. You just need to make the 1 look a very specific way. So what we're going to do is we're going to multiply top and bottom of gigantic fraction by the same thing. As long as it's the same thing, that's the key thing, by the same thing, this means that you're basically multiplying by 1, which is fine. That's the only thing we actually can multiply here. So multiplying by 1. Okay, so what I'm going to do is I'm going to go take a look at this. I'm going to try to just focus in on the denominators of these things. So I see this first part here, this 3 over x, has a denominator of x. So I'm going to take a look at that guy. This next one, this 4, I don't see a denominator there. So what I'm going to do is I'm going to give it a denominator of 1, because everything can have a denominator of 1. So I'm going to take a look at that guy. Then I'm going to take a look at the next one. Like I want all one fell swoop. I'm going to take a look at this 3 over 2. Okay, I'm only looking at the 2. Then I'm going to take a look at this last guy, this 2 over x. The denominator itself is x. I am going to use all of the 4 things that I highlighted to try to come up with what would be a common denominator. So whatever a common denominator would be with x, 1, 2, and x. And I'm going to use that to help me clean this up. So my common denominator here needs to include a 1, an x, a 2, and an x. Okay, well, I see that there's x's in it, but there's only 1 of them. I don't need like an x squared here. So I'm going to put an x in my common denominator list. That takes care of those 2 x's. Then I also see that I have a 1 and a 2. Okay, so I'm thinking of multiplication. Well, if I multiply, let's see, I do a common denominator of 2 with those. So here's what I'm going to do. I'm going to take that 2x that I just came up with. So this guy right here, and I'm going to multiply everybody, top and bottom, by 2x. So 2x on the top, 2x on the bottom, and then I'm going to distribute. And I am allowed to do that as long as the thing that I am multiplying by is equivalent to 1. So if I take a look at this 2x over 2x, whatever I'm multiplying by has to be equivalent to 1, which it is. So I'm good. Just be careful now because we're going to distribute. And I'm not a big fan of doing extra work that I don't have to do. So I'm only going to show this step once because I want to automatically simplify. So basically I'm doing 3 over x, that first guy, times 2x, just distributing. Then I'm going to do plus, I'm going to distribute the 2x to the 4 over 1. So plus 4 over 1 times 2x, all over. This is a horrible looking thing. It's going to look pretty nice here in a second though. Then I've got 3 over 2 times 2 over x, plus 2 over x times 2x. Now, if I chose the correct thing, every single one of these little fractions and fractions business will simplify. So let's look. Okay, so I see, going back to what we did previously, I see an x on the bottom of this and I see an x on the top, which means those can simplify. I also see on the next one, this 1 no longer necessary, so that can go. Dividing by 1 doesn't do anything for us. Then I see this 2 on the bottom and that 2 on the top, so they are going to simplify. Notice all the fractions are disappearing. This is, well, all of the little fractions and fractions. Then I have this x on the bottom and this x on the top. Those are going to simplify. So I no longer have fractions in fractions. I'm just going to have a big, gigantic fraction. So let's do some math here. So I have a 3 times 2, so that's going to give me a 6 plus, and then I have a 4 times 2x, that's an 8x, all over. This 3 with the purple business on the bottom is going to be 3 times x, and then plus I have a 2 times 2, and that gives me a 4. This is my new fraction. No more fractions and fractions business. It's just a fraction. So what I'm going to do at this point now, because x's were in it, I want to go ahead and identify all of my excluded values. So remember, at no point in time throughout the entire problem were you going to be allowed to divide by 0. So let's look. Way back, I see an x that was in the denominator. I see a 1 that was in the denominator, a 2, and an x. Okay, so from those, so inside the red boxes, the only thing that I have there that would have been an issue is if x was equal to 0. So let's put x cannot be equal to 0. Okay, let's go back. We'll keep looking at different stages of this thing. Okay, so with all of the color coding that I did, that was fine. That took care of everything there. Now I need to take a look at, let's get rid of that guy. Now I need to take a look at this very bottom here. So this can't be 0 either. So if I go through and solve that, I think that's going to be -4/3. And that's my answer for this question. Okay, moving on. Oh, we got another problem. So I'm going to do the exact same thing. Turn everything into a fraction. So I see that this 2 is not currently a fraction. Let's give it a 1. Common denominator. All right, we have to take care of all of those denominators that are in there. So if I look here, I have an x, a 1, an x plus 1. That x plus 1 is a package deal. You cannot separate them. And a 5. Okay, so common denominator. What I got to work with, I have to account for an x. I have to account for an x plus 1. I have to account for a 1, and I have to account for a 5. Okay, so let's just pull things out of the list. If I have a 5 only, the 5 will take care of both the 1 and the 5. So I'm going to put a 5. The x and the x plus 1 are not the exact same thing, so you have to use both of them. So I need an x to take care of that x right there, and then I need an x plus 1 to account for that x plus 1. So this denominator is going to be a little bit more involved. But I'm going to do the exact same thing here. I'm going to take this entire fraction, and I'm going to multiply the top and the bottom by 5x times x plus 1. Okay, now I'm not going to show that other additional step that I did on the previous one. I'm just going to try to distribute this here and here. So if I distribute this to the 4 over x, the whole thing, the 5x, x plus 1, the x's are going to cancel, and I'm going to have a 4 left over, and the 5. These x's are going to disappear, and then I still have the x plus 1. So my x here and my x here will have canceled. Okay, let's distribute it here. This has a denominator of 1, which means nothing is going to go away. So I have a 2, minus 2, a 5, an x, and an x plus 1. Okay, let's do the bottom. So I'm going to distribute here. This time, I have this x plus 1 and that x plus 1. Those are going to simplify, so they're going to cancel. So I have the 5. Oh, let's get our fraction bar here. So I still have the 5. Oh, I still have the 3 also. Let's put that guy there. I still have the 3, the 5, and the x. X plus 1s are gone. Plus. Just extend that guy. This time, the 5s are going to cancel here and here. So those are going to go away. I'm going to have a 2, an x, and an x plus 1. So 2x, x plus 1. Then from here, well, we got to clean this up a little bit. So this is going to be 4 times 5 is going to give us 20. 20 times x plus 1 is 20x plus 20. And then this is going to be minus 10x, and I'll do this multiplication next. X plus 1, and then I'm going to get a 15x in the bottom, plus a 2x squared, plus a 2x. Let's clean this up. This is going to give me a negative 10x squared when I multiply, and then this is going to give me a negative 10x, and there's already a 20x there, so that's going to be a 10x, and then a plus 20, all over, I'm just going to reorganize the bottom, 2x squared plus 2x plus 15. Whoa, nope, let's back that up. That's actually going to give us a 2x squared plus 17x. Okay, from here, we need to come up with our excluded values. So why don't you pause it and see if you can come up with the excluded values. At all of the stages throughout the entire problem, you cannot divide by 0. Okay, so if you take a look, I color-coded where my excluded values were coming from. So I have my x equals 0. Well, my x equals 0 cannot equal 0 originated from the original problem. I had an x in the bottom, which I cannot have, and that can't be 0. So then I've got my next one, my excluded value here that is red. That's negative 1. I got that from the original question as well. Is that an x plus 1 in the denominator of one of the fractions? Then this very last one that I came up with, which was negative 17 halves, I got that from the resulting answer there. And if I set that equal to 0, it's got a GCF of x, take that out, then you have a 2x plus 17. So if we solve that, we're going to get negative 17 halves. And then here we have our last question for this set of notes. This is the only one where we actually have some factorization that needs to happen at the very beginning. Well, I mean, it makes it easier if you factor. So I'm going to go ahead and take this x squared minus 1, and I'm going to replace it with its factorization. So I'm just going to pull this off to the side, and I'm going to make this x plus 1, x minus 1, and then pull the x over. So really what I'm going to do is I'm going to negate the fact that that is there, and I'm just going to replace it with its factored form. Pull my fraction bar across, I just replaced it. Now you could have written it down on the next line, or you can keep it where it's at. From here, we're going to go through and do the exact same process. So I'm going to go a little bit faster. You're welcome to pause if you'd like. I'm going to run through this one pretty quickly. So let's see if I go through and I figure out what my denominator is going to be. This is going to be a 1. It looks like I'm going to do x plus 1, x minus 1, top and bottom. Then I'm going to distribute that and start knocking stuff out. Okay, if I distribute it to the first one, I'm going to get an x. If I distribute it to the second one, I'm going to get 3 times x minus 1. On the bottom, I'm going to get a 4 times x plus 1, x minus 1. And then minus x times, and then the x minus 1's cancel. And then from here, I'm going to go ahead and distribute and combine like terms. So it's going to give me 4x minus 3 on top. then this is going to give me 4x squared minus 4 minus x squared minus x. Be careful with that minus sign. This is going to give me 4x minus 3 all over 3x squared minus x minus 4. I am going to factor this and see if this can be simplified. So let's see. I'm going to have a 4x minus 3 on top. I think that can be factored. The 4 to be negative. Okay, so I see something kind of interesting here. If I look at that 4x minus 3 and that 3x minus 4, they're super similar to each other. I'm going to see if maybe they're technically the same thing, just a quick glance on it. And I see that the x itself is attached to the 4. So the only way I could get those to match is if the x was attached to the 4 on the bottom. So I don't think there's anything I can do with those guys. But as soon as I see signs that are super similar to each other, I'm like, oh, maybe I can actually simplify that a little bit farther. But I don't really think that I can here. So from here, I think all we can do is just start listing our excluded values. And with the factorization, that does help me figure out what the excluded values are going to be. Let's put this back in black. So take a second, see if you can figure out the excluded values here. I think the only ones that I could find were back from the original problem when I had my x plus 1, x minus 1, so positive 1, negative 1 can't happen. And then at no other point in time until the very end when I got down to this 3x minus 4 do I have another excluded value. And I think that that gives us our entire answer.